In this video we are going to go over the project's code, the class project. In the description below there is a document describing what was this class project. Hopefully you try to solve it by yourself before looking at this video. So, in this class we are going to finally be able to look at results, so it should be exciting. Let's begin with setting the working directory to the folder that I'm working with, and then I'm going to source to import all the functions from this file, including the getWeather function that we have been using to get weather data. But here I have some named parameters that I'm going to change because I want more data, right? So here I'm going to change from data from more than 100 years because I want to see the results, right, with more years. And I selected this station, which is the Plant City station from the CRONOS database, because Plant City, it's a very old station with a lot of data and more or less reliable data. So I'm going to use it. And just take a look in the code of this getWeather, because we never took a look, because, well, it couldn't comprehend the code until then. But it's just a function that receives the station, the when to start the data, and the hash key, which is a key that you should email the CRONOS maintenance to be able to get one key for you. Each person should have your own key. I have this key for this class, but I don't know how long it's going to work. So, and I just I use these comments that we are not to go over them, but it's just like I read it as a CSV file because it's how I get from the web page. So next I'm going to write this file in a this data in a file, because we don't want to be fetching the here. Okay, I'm getting the data. See, there's a lot of data. It takes a while to get this data, so we shouldn't be all the time fetching so much data from their servers, right? It's a free service. So let's write this data in a file so we don't have to keep reading all the time and overloading their servers. Here I'm just going to read it back to make sure it's working and take a look at the data. So okay, here there is the data from 19th century. So let's start by eliminating the data availability field, because it doesn't have any information. You can see here that it's just composed by hundreds. So I'm just going to make it equal to null. Take a look here, it's not there anymore. Okay, let's take a look at the structure of the weather data that we got. All of that we already did in exercises during the course, right? Like the date of these observations are in characters. We need to now convert it to time. Okay, so now it's converted to time. So we are preparing this weather data to be able to make analysis on them. I know that there is missing data in this weather data, so I'm going to make a which here, selecting which of the components of this data are in A that has missing data. Any, and this is the operator OR, right? So I'm going to return the position of any line that has any of them, or minimum temperature or maximum temperature or precipitation missing data, like with NA, right? So this should be a vector with the position of this missing data. And now I'm going to take a look at the fields itself. You can see that there is quite a bit of missing data, even in this station, and some of them are recent, 2008, but yeah, they are more present in the past days, right, when it was not so reliable. So what I'm going to begin with is eliminating. In the beginning there is a lot of stations have missing data in the beginning, So I'm just going to eliminate all the beginning records in which any of them. I'm going to create a variable that tells the position of the first position in this data in which any of the data is not NEA. Remember that the exclamation symbol make not. So when the temperature minimum is not NA, when the temperature maximum is not NA, and when the precipitation is not NA. Let me see. This happens to be the very first station, but in other stations it's not like that. Some of them have a lot of missing data in the beginning. So okay, I'm just going to assume 0 for precipitation when it's missing. You can see here that there is almost 200 days of missing data in the weather, in the precipitation. I'm just going to assume 0 because, well, most of the days don't rain, right? It's hard to try to calculate what was the rain of a given day without the information itself. You will need to take a look in the stations around, and it's not that simple. So I'm just going to assume 0. So I get all the positions of the precipitation and the missing precipitation. See, it's a vector of positions and make them 0. Okay. So now let's take a look in the temperature. The temperature has a temporal similarity, which means that the maximum temperature of today should be similar to the maximum temperature of yesterday or tomorrow. So the more correct way should be, you know, use that together with a historic mean, or there is packages called weather generators with try to fill these gaps using statistical approaches or other weather stations around. But here we are going to just use the function that we learned in one of our lectures, which is try to make a mean from yesterday and tomorrow, and if you can, if one of these is missing, you just take yesterday or tomorrow. This function is already prepared here in the functions R, so since I already loaded all these functions, it's already ready to be used. I just added something here. I added a print with the number of positions that were fixed, because it's important to keep track of that. You know, like if you have like 3,000 missing data, you know, maybe you shouldn't use this station at all. It's too much missing data. So I'm just going to use this function to fill the gaps. See here, 500 values replaced. Let's take a look in the summary of the weather data now. And now it's no missing data, which is good for our analysis, and the structure is correct, right? Can't be better than that. All of these processes that I did in the weather data, I call it like sanitize weather data. I created a function which basically cleans the weather data, this process that we did, and just it gives me back the cleaned data. So this function is here. It just does what we have seen in this video so far. So I'm just going to execute it. Oh, like let me start again by reading the file again and then sanitizing it again. So okay. Now we are going to start taking a look in the trends. So the first thing that we are going to take a look is the yearly accumulated rainfall. Let's take a look in the function here. So I created a threshold of 340, which means that any year with less than 340 measurements should be discarded, because there is years that I just have like half of the year with measurements, and wouldn't make sense to consider this in a analysis, right? So I just discard any year with less than 340 measurements. So how I do that? I create a new field with the year. So you can see here just the year of the measurements. and then I aggregate them using the length function. So I'm going to get how many there is in each of these years, how many measurements. Okay. And then I will make that the valid years are the positions in which there is more than 340 in this variable that I created. And now I'm going to make an aggregation again by the year, but now with a sum function to sum the range of all of them, but I'm just going to consider the valid years. Okay, and I will put the names on these columns that I created. Okay, so let's make a plot of this data. And oops, I forgot to run here. Okay, and I also going to create a linear regression here because it makes it easier to see how the trend is. So you can see that there is a small increase in trend, right? But it's not that big. It's important to note that this varies a lot between one station and another. So now let's go to the mean temperature, yearly mean temperature. The process is very similar, it's the same, but instead of using the sum, I use the mean and I use the temperature here as the variable. And when I aggregate, I use the mean of these temperatures. So let's plot it and make the linear regression. Well, here we see a strong increase in the mean temperature considering just in the mean temperature, right? You can see that it's almost a degree higher. Let's take a look in the maximum temperature now. It's the same process, but instead of using the mean, I use the max in the function. You can see a small increase in trend. Depending on the station, it's important to note that depending on the weather station, these trends can be quite different. The ideal would be to take the mean of many of these stations to make a more representative analysis. But here it's supposed to be a quick analysis, right? So let's take a look in the number of hot days in the summer. This is considered the days with the temperature over 95 Celsius, 95 Fahrenheit degrees, or 35 Celsius. This is important because it's the days with the extreme temperature, right? What I do here is I just create this new variable saying, is it this day hot or not? With the if-else, if the temperature is more than 35, it's hot. And then after, I just use this this new field that I created in the aggregate. So I just get the information from the hot days, and I count them. I sum the number of them because I put the number 1, right? So each one of them will be count as one day. So we see in these stations there is actually a decreasing trend, but in most of the stations you see a very high increasing trend of the number of the extreme heat days. But like I said, it depends on the station. So let's take a look in the first frost day. This is basically when it's the day of the first frost, the first day in which the temperature gets below 0. And for that, I created a vector with the months that I consider like the end of the year, right? This like from the September to December, and I then separate I create a new column with just the months. Here I create a new column if the temperature was below 0. So true, there was frosting, or false, there was not. And then here I try to find which is the first day in which the frost is true and the month is included in the month that I say to search, right? The fall months. Of course, this will just search until December, and I should search also in January and February, because sometimes the frost just happens in, like this year, for instance, is 21 of January, and still there is no frost. But this would greatly complicate the algorithm, so I'm just going to search for the first day of frost until December. And then the rest of the code is similar, right? I just take the valid years with more than 340 measurements. And let's take a look at the result. And then in this one we see a very strong increasing trend of more than 7 days. And I'm still not counting when the value hits the top here, the roof of the graph, means that this is in day of the year, right? So 365 is the last day of the year, and we can see that a lot of times the first frost happens after the end of the year, and it's happening much more frequently recently. So our first frost day is getting delayed quite a bit. If I were to count also January and February, this trend would be even stronger, probably around 10 days. Let's take a look in the last frost. Now, last frost is the same, but I search from the spring months, and here I use the maximum in the aggregate, because I want the last day in which the frost was true and was contained inside of the spring months. So let's take a look. Here we see that it's getting a little, the last frost is getting a little smaller. It's not that strong of a trend, but it's getting like earlier. So basically we're getting less frostings, like, right? The period in which the frosting happens is getting smaller. And finally, let's take a look in the monthly accumulated rainfall of Florida, which is just an aggregation of the rainfall through the months over all the years. This will just like show like the rain profile of Florida, and we can see that it's exactly what we expected here in Florida, right? November is the driest month. Also May is extremely dry. And here we still have to analyze the first rain of summer, because after the first rain of summer comes, usually starts a big period of intense rainfall here in Florida. So we can see that it usually happens between May and June, and then after that it really increases the rainfall, and then after that it's relatively dry. So let's take a look in the first summer rain. This is the most complicated variable for us to get. So first I define what are the summer months, and I make a new vector here with I'm going to create actually in this form a vector with the sum of the rainfall of 3 days. Remember we took a look on how to do that in one of the classes, and here I separate the month in a separated column. So I'm going to create all these columns to be able to make rules later in the code. So here I make a true or false column called intense rain if the rainfall of the accumulated rainfall of 3 days is bigger than 1 inch. That's what characterizes the summer rain. And I'm going to search when is the first rain of summer, when the month is contained in the summer months, the same process, right? And the intense rain is true, just with the years with 340 measurements. And so here I get like the minimum, right? So it's the first day, because it's the minimum, so it's the day of the year which is the smallest one, and it's containing all these rules that I created. So let's take a look. We can see that the summer rain has been delayed. The summer rain is extremely important for our agriculture because it basically tells us that in the next days it's going to rain a lot. In the next months, I would say, and it's very precise. Always when the first rain comes, it starts to rain very frequently, and we can see that this increasing trend, getting later, and this has a strong impact in agriculture because, well, sometimes you have to some crops can even become not possible because of the season getting shorter, right? It's getting delayed. So this ends our project. In the next video, we are going to create we're going to see how to create a package out of this code, an R package, and also what really are the R package. So, and some closing remarks. Okay, so see you in the next video.